now, so I'll hand over to Mian. As Mian's setting up, let me just say a few words about this. This is something very close to my heart as well. Sorry. Okay. This is to do with computer vision and what we call visual intelligence. Now, you're familiar with biometrics and probably about face detection, facial recognition. What we're going to do is two different applications, and this is related to your PhD students. And one is a face detector, and one is an eye detector. Now, you're probably wondering, why do you want to know where the face is in the image? Well, it's because face in biometrics is very important. Knowing the detection of face, doing the detection of face, is a precursor to many applications like, for example, facial recognition, knowing who somebody is. You need to know where that face is in the image before you go and process the face to say who it is. It's a huge, all of us, the faces in the scene, knowing where people are, very, very easy. When computers do it, it's a very hard challenge, because our cognitive abilities are amazing. With a computer, we only sort of scratching the surface of trying to understand how our processes work in terms of visual perception. What features are we actually using to recognise the face? Now, we can only make a guess at that, it depends. And this system, which Mian uses, is based on a very new technique in literature called age boost. And actually, the combination of what's called a lot of weak classifiers. Now, when I say weak classifiers, very, very simple things, like, for example, you look on the face, what difference between black and white, the difference in the contrast between the two faces can be a weak feature. But that in itself is not enough, because there's many objects around us where there's a big contrast, a dark white contrast. But the positioning of those, and combining many of those together, and sometimes it's even thousands of those features together, can change from what we call weak classification into what we can feel as what we call a complex classifier. And it turns out that complex classifier, which may take many hours or thousands of hours to train, several days offline, it's only offline, can be very, very powerful. Fortunately, in real time, the actual online detection is actually in real time. And this is what Mian's going to show you here. So as you can see, the actual localization of the face there is actually quite robust. But the important thing is, it's not just trained to Mian's face, it's very generic. So as you can see, actually it's picking up something in the background there. Not sure who it is. It's you, I think. And so it's not just a single face, but it will actually pull out and delineate any region, any area in the image which matches what the concept of the face actually is. And say, it's not looking for the geometry, the eyes, the nose, and so on. It's using these combinations of many thousands of features together to build a complex classifier that says this region actually collectively looks like a face. We can actually probably just turn it around, but let's just point it around a little bit just to show. People want to sort of stare at it and see how. Probably have a little more. There we go. Just look at the camera. Oh, there we go. Just there we go. Too bad. Very good. And show me how good it is. I don't have anything on me. Do you have a nose on you? Very good. Thanks, Mia. But just to show how nose, just to show we haven't changed it up. Even if you show it on this, I think I work in the area, and I think that's a pretty good result. And the main thing to try, of course, is to make it all different illumination conditions and so on. But I think you'll agree that's a pretty result. So that's the challenge. Thanks for that. That's the challenge. I don't know again what to say anything more on that. It's part of your PhD.
Yeah, and this is based on Alon's argument. This argument is we have collected thousands of face images from web, and this face images is from different persons, male, female, young man, old man, and also the people from all from countries from all the world, and then we collect this image, put it into the computer, and then what's in face and what is not in the face. This is like the ability. You just give this box ability to know what is human face and what is not human face. As this ability compared to human beings is just like a little baby. So, which means the artificial intelligence here have no way to go. This is more stack. Yeah. Okay.
And I say, this is really important because, well, I'll just give one practical example. I'm sure you're all familiar with Terminal 5 opening next March 27th. everybody going to the airport, whether it's domestic or European or international flight, will all be fingerprinted and have your face taken and so on. So quite a complex set of biometrics will be taken for every single passenger. The guarantee that it won't slow anybody down through the airport, we'll have to see how that works. But I was in a trial in Glasgow a couple of months ago, and it wasn't very, very fast. And what it did actually is take the fingerprints in your face, and then this is at the check-in, I should say, and then at the gate, you have a similar process where you put your hand down, take the fingerprints, and then it matches it to your face, and your face appears, and they actually verify that the person checking in is the same person who's getting on the plane. So it's just another security feature. But it was quite effective, and but face detection is also has a very wide-ranging application. Anything from detecting terrorists potentially through to even game playing. Game playing in the future won't be keyboards and mice and so on. It would actually be controlling the characters using your head orientation, your face orientation, your gestures, your hands, and so on. So that's faces. Now this is the other one you've got here is eye detection. So narrowing down to the eyes and the face. Now, this is important for many other reasons, actually. To give you an example, retail outlets are interested to know where people are actually looking when they go shopping. So you go around the store, you look at the layout, you want to record where you're actually gazing, what kinds of things you're looking at. Are you looking at the product of those things? Similarly, it's used a lot now with things like being adverts into games. Now, I'm not sure if you're familiar with augmented reality. This is where you may well have seen it during final matches on television. It's where you have a broadcaster broadcasts in your own country a football game, but actually the images that go down the side, the advertising down the side, the hoardings down the side of the pitch, are actually computer generated. So the complex bit of software knows exactly where the camera's looking at, knows exactly where the image projects the adverts or relevant to your particular country. So the same match is being watched all around the world, but the adverts are different for each country, obviously. Now, why is this important also for this? Well, the relevance is that many researchers are interested in, and even advertisers are interested to know, when you watch television or watch a football game, where are you actually looking? Now, you think, well, yes, I'm watching the players and watching the interaction with the ball and so on, but what you probably don't appreciate as much is that actually your eyes do the saccades and they do actually look at the adverts as well, even if you don't consciously know it. So what you can do is you can have software like this, which replaces now very complex bits of head kit, which is just very similar. You can use software like this to record exactly where you were looking during the game. They can then change your advertising or whatever they want to change in the scene, do the same thing again, and judge whether you are looking at those adverts or more so in the new configuration.
Are you actually developing systems and then finding applications for them when they're happening around?
It's both, but retail monitoring and, for example, knowing where advertisers, they're sort of ones to come to us saying we want good technology that can do this. Very, very interesting. And as Mike will mention later, the same applies to websites as well. When you go to websites, advertisers want to know where to place their adverts. And again, subconsciously, you do look at things, maybe click on them because you find them interesting. But it's the exact placement of those ads on the website that are so critical to whether you actually go there and see something.
So I'm just thinking down to business is more likely to come to you and say, yeah, we want this, something to do with this rather than, oh, well, I've invented a widget, what can I use it for?
Well, you're right, but sometimes they don't even realise you can do this. The fact that it's technology can actually know exactly where you're looking. Same with films as well. Product placement of films is increasing, as we all know, and it's very careful research to exactly where those things appear in film and exactly for how long, to make you aware of them. Very interesting stuff. Does anybody else want to try? Does anyone else want to try? There's a chap here, I'm looking at glasses and they're grabbing his attention. Do you want to try this?